Here's the second part of video 5. We're just going to talk about kinetic theory along with this. Of course, let's get moving, right? Kinetic, motion, energy. It's saying that the kinetic theory of matter just states that matter is composed of large numbers of molecules, individual atoms or molecules, that are in constant motion. So everything around you is moving. I know that freaks people out. The closer, though, we get to absolute zero, which is negative 273.15, Celsius, we are then slowing down. So even the particles in your hand, he wigs you out, you're moving, okay? Every particle is moving. The dust you're sitting in, the particles, or the book around you, the particles are moving, okay? They're vibrating, translating, rotating. This theory is also called the kinetic molecular theory of matter. Not that that really matters, the kinetic theory of gases, etc. All kinds of different things that we can talk about. They are random and free to move around, etc. So we talk about two main terms here today that we're going to talk about with gases is that they can either effuse or diffuse. Now, effusion, I guess I'll say it even more like that, is the ability of a gas to travel or escape through a tiny hole from a place of high concentration to low concentration. Now, a lot of people ignore that part because why would it move unless it was getting out of a place where it's really congested and then it's like, okay, let's get some air. Whew, literally saying that on purpose, okay? So you can see effusion, it's going to escape through a tiny hole, like maybe even a balloon. When you poke a hole in it, whatever, it's going to effuse out of that balloon, okay? Now, there is a law called Graham's law of effusion. It has to do with the rates of effusion compared to the molar masses, and we can tell that which gas is going to move faster or slowly. They're inversely proportional to the square root of the molar masses. I know that sounds like a lot, but it's just math, and you can plug in those numbers if you have them. We're not going to do a whole lot with it because I'll show you a little video on a really cool thing about how gases move and using that, but it is not going to be something I necessarily want you to calculate, but it does give you this point. Now, this is the main thing that we will be applying, okay? This means that lighter gases will effuse or diffuse, we haven't talked about diffusion yet, quicker than heavier gases. And that makes total sense. The lighter you are, the faster you can move. Even think about people. I'm not being rude or anything. It's just like, okay, if you don't have as much mass, you can move faster, easier, right? Even doing like a pull-up, you don't have to pull as much, like you can go fast, okay? So the heavier you are, of course, the slower you're going to be because you're dragging along more weight, right? So heavier gases then are slower than lighter gases, of course. So we just look at what? When we talk about heavy or light, we're talking about molar masses, guys. The periodic table, look it up, add them up, and you know. Diffusion is the amount of particles can move and mix through space or any other substance, so like from high to low. So there's no barrier. That's the big difference here, okay? So here, there's a barrier and it's moving through some kind of tiny space or hole or something like that, whereas diffusion is just like, it could be in a big room, okay? Like when you smell something, say someone's cooking something really good and you're like, smell that barbecue, okay? Or whatever it is, okay? So it diffuses, those particles move from the barbecue to your nose, all right? So again, there's the differences. I'm not going to read them to you, but you guys can learn them as we go and read it yourself, all right? Which of the following gases most fuses most rapidly? It could be diffuses, it could be moves most rapidly. I could say a variation of things. They can put in fancy words or not. It doesn't matter, okay? So which one will do most rapidly? So most rapidly means fastest, right? So just to be clear on our question, let's make sure of that. So what do? We just need to know, how heavy are you, okay? Or how light are you? So nitrogen, we do have to know the formulas, N2 because it is a diatomic when it's all alone. Nitrogen, I go look at my periodic table, it's 14.101 times 2 is 28.02 grams per mole. Now this is called showing my work, okay? I'm not just going to circle an answer and say, yeah, take that. No. I'm going to need to see work on these. Oxygen, O2, okay? Now, if I'm going to give you a substance we're not familiar with, I will give you the formula, okay? Or at least I think make sure you're not having a problem with the formula. It's just the process. So we looked up oxygen, each of them 16, so that's a 32. I don't know why I put the equals there, but 0.00 grams per mole. So far, oxygen's going to move slower because it's lighter, right? Nitrogen will move a little faster. We have ammonia. Now, if you don't know ammonia, you can look at ammonium. The ion is one less hydrogen and no charge, okay? NH3, that's the weak base that we know is in Windex and all kinds of things, fertilizer, etc. So we have 14.01 for the hydrogen, 1.008 times 3, right, for the lovely hydrogen. So that is 3.024 plus the 14.01, we get 17.03 grams per mole. Oh, look, that's the lightest so far, so it's going to be the fastest so far. Let's see about this carbon monoxide stuff. That's that silent killer that you got to be careful of. Hopefully everybody has a carbon monoxide detector on every floor of their house that can beep at them to let them know, because woof, we can have issues. Comes out of your car engines. 12.01 is the carbon, 16 for the oxygen. Let's add them up. There's only one of each. So 16 plus 12.01 is 28.01. Wow, that's really, really, really close to nitrogen. So our sig figs are going to matter here. So carbon monoxide is going to move just a little bit faster than the nitrogen. So which one's the most rapid? Well, this one, because it has the what? It's the lightest, the lowest molar mass. Okay. Now we could put these in order. So that's another question I love to ask. Another test question could be this. I could say, hey, list in decreasing order of speed. So we'll use the same gases we had here. I can obviously mix them up. Okay. So decreasing order, here's what I would want you to do. There are 4 gases. Okay. So we're going to put them like this, and I want to decrease. Here's where a lot of people mess up. They'll put them in the wrong order. Decreasing order means who? Decreasing speed means the slowest is going to be here, which means the heaviest, sorry. Whoa. See, this is why we do this. Wow. And then on this side is our fastest, because we're going from the fastest to the slowest as decreasing, and that means the lightest. Sorry. I don't know why I wanted to do that. All right, so now we just fill them in. So who was the lightest? We already said the fastest would be ammonia, NH3, with only 17.03 grams. And next, very, very, very closely, is carbon monoxide, and then nitrogen. Yeah, they're really, really close, so make sure of that. Now remember, we could put, signs in between. It's going lighter, less and less and less. And the slowest, of course, out of all of them would be oxygen in this case, because it's 32 grams per mole. Okay? So you have to find the molar mass first and then answer the question and understand it. Okay? You can read about ideal and real. Of course, we really only have real ones in the world, but we deal with ideal. We say they're ideal so that we can deal with them. Okay? So see you in class.